everybody. I'm not sure if the videos will work because we kind of shifted around here, but that's okay. Let's get started here. I'm going to get rid of this. Okay, so I like to start my pesticide talk a little bit, just kind of putting this out there in the front, just to keep everybody thinking about all the stressors that our beekeepers are facing right now. And that includes a lot of these environmental stressors, the management aspects, the varroa mites, the pests, the diseases. And I really want to kind of bring this up at the very beginning because it is a pesticide talk, but they are so interconnected. These stressors are interacting with one another in complex ways that makes it very difficult for us to determine what is actually causing our colony problems, our declines. Varroa, yes, that's a given. Failing queens, poor nutrition, pathogens, pesticides. I like this up right here in red because what are we doing to address these concerns? We've got a lot of research and effort going into varroa control management. A lot of great breeders and efforts trying to select for certain traits. Wonderful people working on nutritional supplements and other things to add additive stuff. Pathogens, a lot of people working on antivirals and things to address that. What about pesticides? What do we do about pesticides? There's very little work being done in terms of what do we do in terms of the chemicals that are coming into the hive themselves. There's a lot of policy work, a lot of discussion on how to try to control or reduce chemicals from the environment. And I talked a little bit about this yesterday, where I'm trying to distinguish these traditional bee kills or these classic acute lethal exposures versus these incidences where an exposure might not immediately kill the colony, but might alter their behavior, development, reproductive, and habitat in ways that really inhibit their success. So another way of looking at this is that in this lethal acute exposure, you've got individual level effects, meaning this bee died, that was an effect on that individual. Here's a pile of dead bees, that's a colony level effect. So we want to think about these things as what is affecting the individual bee and what is affecting the colony. Then you also want to look at these in terms of their direct effect versus their indirect effects. So you've got direct effects, meaning that it's directly killing the bee, directly killing the colony. But in this area, there's direct and indirect effects. And a lot of people aren't really sure what the difference is. So I want to go through this kind of diagram. The effects of environmental insecticides are quite complicated. But just to summarize this, the highest individuals at highest risk are going to be your foragers, right? They're flying in and out of the hive. They're being introduced to the environment. A lot of times we look at this and we see either a pile of dead bees, and that could be because the exposed foragers immediately died. They might have died away from the hive, which is an individual level effect. But if they came back with contaminated food stores, that's a colony level effect, and that's highlighted in blue right here. So I want you guys to think about how this flows because there are direct effects as well as a suite of indirect effects that happen. And I talked a little bit about this, but right now what we're seeing is that the colonies are not outright dying, and so beekeepers aren't really sure what to do in terms of action. It's not a clear-cut case of a pile of dead bees like I have at NREC. But what is happening is that we have these weakened colonies. And I think that there's a number of things happening in terms of the indirect effects, including precocious foraging, because if foragers are dying outside the hive, you have to recruit house bees to take that on. They're going to be shorter lived, they're less experienced, they bring back less food stores, but it also leaves a number of individuals not doing in-hive tasks, grooming, brood care, hygienic defense. So it increases their susceptibility to other pathogens and diseases. Now, they're coming back with contaminated food stores. They can have direct effects on the individual queen, as well as the brood and the workers and the nestmates. So there's these really important kind of nuanced indirect effects and shifts in their colony function that can really exacerbate the introduction of some of these other things. So now you have varroa, you've got nosema, you've got viruses, bacteria, secondary pests, agrochemicals, beekeeper climaticides, poor nutrition, migratory stress, overwintering stress. You can summarize it by there's a suite of these biotic and abiotic stressors that then could ultimately kill your colony. You start off with something weak, And it could be a number of combination of things that finally just kind of kills and ends up killing the hive. My point here is you guys understand these interactions between pesticides, pathogens, ectoparasites, hive pests. And again, we're talking about environmental pesticides, but there's really little being done for beekeepers to address this. And if we don't get a handle on that, where are we going to, we're not going to make really good progress on the other things in terms of breeding and management of pests and management of pesticides. So this talk, or management of pathogens, this talk is kind of combining some of the work that I started in here at Washington and all the way through. So a lot of people are already familiar with this. This is a classic study that showed there's over 120 different kinds of chemicals in the comb, the pollen, and the bee samples. Many of them are systemic, meaning that they are chemicals, either insecticides or fungicides, that can move from soil into the plants. And so that's oftentimes where we think that the bees are getting it is from the nectar and the pollen. There are a number of these beekeeper applied chemicals as well, but the concern is that these mixtures, this chemical overloading or mixtures of chemicals may have additive effects or synergistic effects where the combination of them can be quite accumulating. Okay, so this is work that I did as a master's. Steve had a really great research question that continues to boggle my mind and continues to encourage me to look at this issue. But when I was here as a master's student, we set up an experiment where we looked at dirty comb and clean comb. We literally cut them out of combs from dead out operations that reported CCD, and we caged the queens on there and we looked at their development. So there was these clean combs versus these dirty combs. They range from 14 to 17 different individuals. There were certainly a lot of emphasis on the in-hive treatments at the time, but that hasn't changed very much. I mean, there has been some changes in chemistry and what you see in the residues, but there are similarities in terms of the numbers of chemicals and just the fact that there are this diversity of small exposures. So we caged the queen, we marked the development, and we put those through these experiment. And what surprisingly we found was that in these clean combs, you have these normal developmental stages. You have the egg stage in green, you've got young larvae in purple or maroon, late larvae in orange. And you can see here that there's this weird shift where there's a good proportion of them not reaching that larval stage. So we kind of noted this as kind of delayed development. It's a weird expression of the larvae aren't growing right. Some of these become aborted, some of them are cannibalized. We noted that there was another three combs that's had similar effects. It wasn't just one frame. We saw this multiple times where 80% of those eggs were then removed by day 8. So they had stunted growth, but then they just kind of didn't reach adulthood. So we suspect that this is contributing to that spotty brood pattern issue. A lot of people are now starting to be able to interpret brood frames, and this is part of the reason why it's incredibly important, that the brood pattern is an indicator of the queen health. Is she laying well? It's also an indicator of brood health and brood care. Are those eggs reaching pupation? So spotty brood patterning can have impacts on the colony as a whole because you can reduce their care efficiency. Now they got to go all over the place to feed their larvae. It reduces egg laying efficiency as well because now the queen has to go everywhere, and it can disrupt these thermal regulation. There's a number of different causes that can lead to spotty brood pattern, but a lot of times the beekeepers are quick to blame the queen. And so I want you guys to think about these factors as, is it really the queen or is it the colony? Okay, so in this experiment, we cage them, we monitor their development, and then they emerge as adults. And this is typical emergence, comes out 2021. What was interesting is because we reuse these combs over and over again, we started to see a shift in the number of bees that were starting to emerge at a later date. And we think that that is likely caused because you have clean comb, you have dirty comb, and at some point, some of the saturation is going to migrate into these clean combs. So why we mention this is because it's important and it's related to Varroa. I'm not going to go into this too much because you guys already had a couple of Varroa talks, but I do want to point out the fact that if you've got worker brood here, Yeah, worker brood here. Mother mite produces a male progeny, and then first daughter mite has 94% chance of survival. Second daughter mite has a significantly reduced chance of survival because it's racing against the host breaking through that cell. With drone larvae, you have greater success of survival at first daughter, second daughter, and even possibly a third daughter. So the point here is that in drones, they have an additional 2.5 days of development, which allows them to create about 2 to 2.5 mites per daughter, or number of daughter mites. So this is a number of daughter mites that can be produced in one drone cell versus worker cells. Well, if there's delayed development here, there could be potential where there are situations where there are mites producing at higher levels than they should be. So there's that. So there's significant concerns with managing varroa. And if we are creating a habitat where the brood is significantly growing slower or having problems in their development, which gives varroa an advantage, we want to kind of nip that in the bud before they get too susceptible. So, or too far gone. So with these bees, we emerge them, we put them into a longevity test and a susceptibility test. The longevity test showed that they did live shorter, but the susceptibility test was really interesting. This was a collaboration with Dr. Smart, this is my spouse. She was also a master's student with Steve at the time. And there, at that time, the experiment was manipulating hives so that they would have low varroa, normal nosema loads, high varroa and high nosema loads, looking at the interaction between these varroa levels and nosema. What I did was I painted my bees and I distributed them evenly into these different hives and then resampled them at week 2, week 3, week 4 of their post-release. So looking at what their susceptibility to nosema was, I'll just say there was no difference in mite loads between the treatment, but we did find some really interesting results with nosema. Now this is kind of a complicated graph, but the bars represent the proportion of individuals infected. So right off the bat, you can see that the number of bees infected was significantly higher in the young bees and middle-aged bees and even older bees. We know nosema typically affects the older bees, but the level of spores also increase with age. So this showed that with a dirty comb, they become more susceptible to nosema. They also might be producing or giving varroa an advantage. So moving on, I went to do my PhD with Marla, looking at neonicotinoids, observation hives that were free foraging. And we were feeding these colonies. These were 1 frame, 2 frame, and 5 frame colonies, really just feeding them neonicotinoids in a very small dosage and sugar syrup, and looking at their egg laying response. So this is pretty a pretty good range. All right, and then using observations, we marked the queens. These trails show her path within a 15-minute observation. These circles indicate the number of eggs that she laid. You can see some queens were very active, laying a lot of eggs, whereas some barely moved at all. Are you going to work? Let's see. I know that shifted a couple times. So. Oh, yay, it works. All right. Now here's your queen. She's looking in cells, she's actively moving, she's looking for a place to lay. As opposed to this one, she stuck her head down in the cell and seems to have fallen asleep. But that was something that I saw quite a lot. They're alive, but they're not really acting like normal. And you can see here, it didn't matter if it was 1 frame, 2 frame, or 5 frame, your controls had significantly higher average eggs laid per observation than any of the treatments. So why I bring this up is, it's not stopping. Why I bring this up is because, in the last 10 years, what I've learned is that a pesticide doesn't have to kill the bees to harm the colony. And that's the messaging I've been trying to bring to regulators and policymakers, is that all of our protections for pollinators with pesticide is based on whether it kills or doesn't. And there's a lot of different ways in which these colonies can be impacted. You notice that one colony looked normal, there's a lot of bees walking around. Same colony, 50 parts per billion clothianidin. They're alive, but are they bringing in forage? Are they laying eggs? Is this colony going to be successful in overwintering? Not if it's not doing anything. So the other thing I wanted to point out is that it's really important to not detach, queen quality pathogens, varroa mites, and pesticides, because they all interact with one another. So looking at in-hive, you can see that there was a huge difference in in-hive activity. We use hygienic behavior as just a method of assessing their activity inside the hive. So hygienic behavior is often used by the breeders to determine whether or not they're removing their diseased and infected brood. We're using it here just as a measure of their activity. And in the blue bars, this is pre-treatment, significantly or not significant across the board. They're all pretty good in their hygienic performance. But then after treatment, these higher doses had hugely different hygienic behavior responses. And I try to emphasize this because a lot of times I hear people say, you sold me a hygienic queen and it's not doing what it's supposed to be doing. It's not always the breeder, it's not always the queen. This is a situation where the chemicals being introduced into that hive significantly alter their ability to perform in that hygienic manner. So this is why I think it's really important for us as an industry to start addressing pesticide-related issues. If we want to make headway with varroa, with breeding, with pathogens, we need to address this. Beekeepers need to figure out a way, and it's just to empower the beekeepers rather than pulling your hair and screaming about pesticides, proactively monitoring for incidences, figuring out what happened, seasonality of losses, duration of losses, rate of losses, identify ways to mitigate those impacts with comb replacement, apiary replacement, protection plans, habitat enhancements. This is what I did to essentially find out what happened to my bees at Altent. And essentially the recommendation, and I can't go through all of them because I don't have time, but integrated pesticide management for beekeepers really starts with like the miticides that aren't going to leave a lot of residues, aren't going to leave a lot of extra chemicals in your hive, alternating these hive treatments if you need to, rather than upping the doses, changing them up, open dialogue with landowners, farmers, and et cetera. This is what I'm going to talk about right here is abnormal bee loss, spotted brood pattern, and regular comb replacement. But that reporting incidences is also really important. So I'm not going to talk about this because you guys already kind of went through it, but I will mention that there are these synthetic treatments and these organic and compounds. And I just want to mention that natural and organic compounds, they're not going to, oftentimes they are thought of as less toxic, but they can be more toxic. They can be toxic to bees. What we're talking about here is whether or not they leave residues in the hive. Many of these organic acids don't leave those residues. There are some oils and patties that will leave residues, but it's mostly these synthetic compounds that will leave some kind of metabolite or residue. If you really want to know, this is a great link. You can kind of look at these types of chemicals and when to use them and their conditions for use. So monitoring for pesticide incidences, this is what I really had to work on, like finding out how to deal with it. Incidences may be very difficult to see. A lot of times we put our colonies on mulch or on grass, and you can't see the immediate losses here, but all of these colonies are being impacted in the same manner. And this is, continued losses just over time. But if it's lost in the grass, you really don't have a sense of when that loss happened. So we had several students, Jennifer Weisberg, I think I showed in the other picture, she's working on dead bee trap to try to help us figure out what was going on at the Altent site. She was painting these bees, looking at optimal trap sizes. But one thing that was really interesting that we started employing these traps, and this is at 3 different sizes. This is the NREC site, our urban teaching apiary, and then an orchard farm site. And we set these traps up, and we noticed that there are significant differences in the timing of losses, and that some of it can be traced back to a practice, like they are spraying for fungicides on the orchard in early spring. It's very likely what happened there. In the urban teaching apiary, we found, and we started asking around, there was some mosquito sprays that were happening along the creek, which might indicate this. These are not losses that are going to kill my colony, but this one right here was just, we tried the year previously, we tried to put them in beginning of May. And then this following year, we put it in late because we were thinking, let's avoid corn altogether. Let's avoid planting. Let's see if that fixes things. And this is what really helped us determine that this is a long-term chronic exposure that's happening. It's not related to a practice. So we started asking beekeepers to try to employ this trap system to see if they would be able to identify what we call regional losses or seasonal loss patterns. This is one example in Kansas. Each one is a different trap. These three are three different beekeepers that knew nothing of each other, but they're about 20 to 30 miles apart from one another. That was really interesting to see that all of them had the same spike in losses around the same time. Well, now that gives me as a researcher more leverage to go and find out what was being sprayed at the time. What are the outbreaks going on at that time? What are the urban practices to try to backtrace why that is happening? I strongly encourage people who have repeated losses in a location to maybe try this. It's not for everybody. It is a little bit time consuming, but if you have sites where you suspect you have pesticides, it's really important to try to catch them on the onset rather than weeks later, because you can't investigate it after it's all dried out. This allows you to narrow down that window of exposure, reduce the number of target chemicals you have to test for, and eventually help you identify those practices that might be harmful. Some of those examples might be the tank sprays and mosquito abatement, cosmetic pesticides in urban areas. But I'm trying to find ways to refine the testing and reduce the cost for beekeepers. There is a better understanding of, using these traps. There's a better understanding of which chemicals or practices and when. They're easy to develop. You don't have to have a trap, but if you have a surface you can clean off regularly, then that gives you a chance to kind of look at it. I'm not saying you have to clean your traps every week, but if you had something once a month, you go out there, you'll notice a difference if you have an uptick of losses. Another thing that I found really interesting is what's going on with this hive? What's wrong with it? These bees found in the traps. Besides the fact that they're dead. Notice how fuzzy.
Freshly born.
Yeah, they're newly emerged, right? They're like nurse bees. Should you have nurse bees in your dead bee traps? Why would nurse bees potentially be in a dead bee trap? What do they do differently than any other bee in the hive?
Yeah.
They do, but what else do they eat? A lot of. So if you have contaminated pollen, it's being brought back on the legs of the foragers. They're not consuming it. They're bringing it back. They're working it. If you have contaminated pollen, that might result in a loss of your nurse bees. And if that's the case, what does a beekeeper do if they see a pile of nurse bees in their dead bee traps? Boost it with a frame of sealed brood. Not every colony in your apiary is going to be impacted by the same chemical exposure. They're foraging in different areas. They're foraging on different things. There are ways to mitigate complete losses of these colonies if you can recognize when they're struggling. So the loss of nurse bees in a hive is important. You should be finding these normal tattered foragers. Dead, dying nurse bees indicate that there might be something going on the pollen that might then impact your brood. So that spiraling down effect or the negative feedback that then causes the queens to reduce their egg laying. So again, I ask, is it the queen or is it the colony? Don't always blame the queens. It's sometimes the environment that they're in. What about this one? Yeah, nice one. Yes. So surprisingly, all the citizen scientists that employed the traps, many of them had suspected they had issues with pesticides. Several of them was actually having ineffective varroa treatments. They were treating like they always have, or they started a new treatment. In one case, he's like, I do my varroa treatment. I started using the vapor. I said, it's all, I'm doing everything that they say. And I'm showing them the bags of, wow, your pile of dead bees show a lot of mites there. Turns out he wasn't plugging his hive right, So there's a lot of these little things that new beekeepers or smaller beekeepers aren't quite getting. And they think since I threw something in my colony, I should be good to go. If this was a way for them to really see, no, you have a varroa issue. It's not a pesticide issue. What about this one? That's not a pesticide.
Queen.
Yeah. You can actually tell a lot before you even open up the hive. And I'm encouraging beekeepers to just take some time to look. The other thing I want to talk about is comb replacement. There are clear advantages and disadvantages. A lot of people understand that there's a diluting effect. You can reduce all these different things, but the disadvantages is it's costly. You don't see immediate results. There's a very need for replacement. So if you replace it too often, it cuts into your honey. So you don't want to over replace and you don't want to under replace. Well, when do I need to replace cone then and how often? This is something I've been trying to work on to try to help beekeepers determine. But science look out for our old dark thick combs. I have started encouraging people to, for those of you that actually look at each frame or do for thorough health inspections, mark your problem frames. I'll talk a little bit about those, but diseases, spotty brood, in-tune pollen, or it just smells funny. There are frames that you pull out and you're just like, ooh, it smells like there's a lot of brood loss here. I'm not sure if you want to be continually putting those back into rotation. The recommendation is to replace 3 combs per box. And I'll tell you that's not based on any science or any number. There is no good recommendation right now. It's not clear cut and it's too demanding to replace that much. So this is what I'm proposing for us to try. This is called the performance check. I do the 3 strikes you're out way. And this is going to be different for small scale and commercial beekeepers. Because small scale and hobbyist beekeepers take the time and they might be able to have time to go through each frame. Whereas many of these beekeepers are working at the colony level. So what I do is if I'm inspecting a colony and I see this horrible brood pattern, I'm going to pull that out. It's still got food, it's still got pollen, it's still got maybe 200, individual brood that might come out. So I leave it in there, but when I'm making up packages, when I'm breaking down my losses in the fall, I'll mark these colonies. If I see this, if I come across this, I'll mark the top of the frame. And when I go through my inspections and you're starting to make up colonies with your old frames, if I see marks, multiple marks on the top of that frame, I know that I've inspected this 3-4 times and it's continually performed poorly for me. I don't know why. Maybe it's spotted brood pattern, maybe it's varroa, maybe it's disease. But even if it's varroa, if you have a lot of varroa brood losses from varroa, you might also have viruses being harbored in that comb, right? So what I'm trying to do is try to create some kind of method so that people can kind of cull them out as needed, as opposed to just willy-nilly picking something. The color code, you guys all know the international color code, right? Using queens. That's usually what I have in my holster, is the pen marker for that year. If I see a queen that's unmarked, I'll mark her. So that's what I've been doing, is just using my queen marking pen and marking these, either the whole box or the frame. And this allows me to say, well, I know I've had losses in 19. I didn't have a loss in 2000, but I had 2 consecutive losses after that. Maybe it's time to get rid of that box and the resource in the comb. Some of our students are showing that reusing these dead out combs can inhibit the colony's ability to rear a queen. Well, I don't want a colony to be really strong and swarm and then not be able to replace itself. So what's going on here? This is a great example of not great comb, not great brood. Can you guys see what's going on? There's some things here. Let me do this. How's that? You see what's going on? They're looking a little misshapen. They're slooping down to the sides of the cells. They're not discolored. They're not distinguishing in any kind of particular symptom, but they appear dry, like they're falling towards the cells. Well, my question would be, is there enough food? Is there enough ample jelly? And I can see that in some of these cases, there's not, right? The green shows this little larva sitting on a dry cell. So now my question is it the brood care? Is it nurse bees? Do I have brood of all stages? Do I have dead emerging brood? Do I have mites? There's so many things that you have to go through, but a lot of times I get called to get inspected and the beekeeper wants to know, well, do I have this? Do I have AFB or European foul brood is one that is a big concern kind of, in beekeepers around. And this is a stress disease. It can be caused by poor nutrition. It affects the gut. It doesn't form spores like AFB, so it's not as persistent. It affects these unsealed young brood, and they can kind of have these twisted, melty yellow stuff. It's unpleasant, sour, smell to it. And then this one, a lot of people want to know whether they have EFB or the crud. And the crud is also another stress disease. It looks like it's a combination of things, from viruses to these different pathogens. Mites may or may not be present, so it's not entirely associated with mite lobes, but it's the running hypothesis is that it's just a cocktail of these different pathogens going awry. So a lot of beekeepers want to know whether they have this or whether they have that. So I've been trying to show them that it's not, maybe we need to rethink our perspective on these stressors. So let's play a little game here. Here's these larval symptoms associated with crud, right? It could, because it's a combination of stuff, I think it's coming up. Oh, it could be a whole assortment of things, depending on where you are and what they're expressing. Well, you got all these other things, right? You got AFB, you got EFB, you got fungal diseases, you got viruses. And if you start mapping it out, they all have very similar symptoms. The one you don't want to play around with is AFB, and they do have that ropey diagnostic feel thing, so you can kind of determine that. But my point is that, you know, for beekeepers that see consistent and similar EFB symptoms and widespread infection across apiary, then you should think about contacting your vet and getting some antibiotic treatments. But if you just see a couple or a couple dozen of infected larvae, or you see these random symptoms, affected pupae, and you're not sure what exactly is happening, you might want to consider other factors. My point being is that think about the triggers, EFB and the crud. Well, EFB is definitely kind of triggered by malnutrition or sporadic forage, or causes immune suppression. It can be triggered by loss of workers, either nurse bees or foragers. It can be triggered by high bite loads or pesticide exposure. But so can the crud. So this might be a little controversial right now. As a researcher, you know, I think there are situations where you have to address an outbreak. But for a lot of new beekeepers and small scale beekeepers, they're fretting about a handful of larvae on one frame. How many of you see one frame of bad spotty brood, but the rest of it looks good, right? Do you guys do something about that one frame of spotty brood? You leave it alone. There's some people that, you know, panic and want to get the antibiotic, or panic and want to change their management, add more stuff to it. And I feel like maybe it's not as important for us to distinguish whether you have EFB or the crud, but rather focus on the stress, because it's likely that you have them all. It's all in there. It's just whether or not the larvae are expressing it. So what I'm trying to encourage people to do, it's not fret about whether you have this or this or this or that and how much. Look at the triggers and how to mitigate those triggers. If it's nutrition, hive placement is critical. Plant more diverse forage. Supplement the diet if needed. If it's loss of workers and cohorts, you can determine that through your hive inspections. Checking for brood stages and patterns. Marking your queens and making sure that what you put in there is still there. Checking your food stores. Supplement with sealed brood if needed, and requeen. If it's mite loads, start regularly monitoring at the apiary level. Have a mite management plan. And more importantly, like Ramesh said, double check after you treat, because sometimes it doesn't work, or you did something wrong and it's not taking down that grow level like you want it to. If it's pesticides, hive placement is important. If you have chronic losses or suspect abnormal losses, set up some dud bee traps and figure out when and why it's happening. Good communication is important, because then you can kind of see what's going on in your neighborhood. The miticides are important. Replace your comb. And lastly, I want to do this. Report. They don't know we're having problems because we don't want to report. And I really encourage you guys to report to EPA and your Department of Ag, because that is critical. All right, that's it.
We have time for a number of questions.
Sorry, I talked a lot.
George?
I don't know if I understood you right, but you mentioned that if there might be virus carryover on old combs. I thought viruses only lived on living.
No, yes. I mean, like if you've got remnants of old broods, a lot of people have a dead out, they just take the comb and add it to another box. You know, and I'm not talking about it's been stored away or it's been, there's been time lapse. Sometimes in the operation, we're like, oh, this colony's doing really good. This one died. Why don't I give this box to that colony? That's what I mean. And then there's leftover brood that's still kind of alive but dead, you know. So you don't have to worry about that. Yeah.
It was on one slide and it went by really fast, but you said something about replacing comb, and in the same slide you said replacing frames. Are you distinguishing between the two?
Yes, because there are different beekeepers that run different operations. So what I mean is that, you know, for smaller scale beekeepers, they take the time to go through and do their hive inspection. And in that case, maybe marking the individual frames might be more appropriate for operation. For those larger scale beekeepers that don't go through every single frame, when they see a dead out, I'm encouraging them to mark the box, because then they're working at a higher scale or a higher level. But I don't know. I mean, I haven't had a lot of beekeepers try this yet, so I'd love to get some volunteers to see if we can start tracking our dead outs and doing a better job at replacing the comb and the resources that consistently perform poorly. I don't think we're gonna get as far as we should with varroa, with breeding, with all the things that we're doing, with all the other stressors, if we don't take care of the pesticides and the accumulation of it in the comb. Yeah.
What was the issue with entombed pollen?
Entombed pollen is this really interesting response. You know, Van Ingels wrote a paper about it in 2009, and it's basically, you can see the cross section here. They're taking pollen cells and they're entombing it, meaning they're covering it with a layer of wax and propolis. They're kind of warding other nestmates from consuming it. So when he dug that out and had it tested, it was nutritionally kind of low. It's like got, I don't know, some weird husks in it, but it also had quite a lot of chlorothalonil, which is a fungicide that's commonly used in ag systems. So they suspect that these bees are responding to something when they consume it, and they're warding it off to prevent other nestmates from consuming it. But there's not a lot of information of what those triggers are or that response.
Okay, another question. So that one graph where you had the farmers didn't know each other and had that huge spike.
Mhm.
Then following that spike, it dropped right down to the bottom line. What's that?
Remember, these are just losses, and they're really minimal. And you're talking about a 30,000, individual hive. We're just trying to find timing of losses. That spike, it was just the next week he didn't have any losses. So
okay.
so this just represents the number of individual collected in the trap itself. So they had 3 that died the following.
But then it bounced right back up.
And then it bounced right back up. Yeah. And like I said, some of these citizen beekeepers didn't actually have a pesticide problem. They had a varroa management problem. But again, this is not, I mean, this spike is alarming, but these are small numbers. These are not like alarming numbers where I think it's going to crash the colony. That's not the point of the traps. The point of the traps is to try to figure out, is there a seasonality or pattern to the larvae where we can then tie and say, look, it's associated with this pest that breaks out in this area the end of June, and what are they spraying for it? That will give us a shorter list of chemicals to test for than the whatever 180 compounds they look for now.
You get bee trap with young bees. Those of us do pollination and almonds in particular, but in other prefruits will notice, and it's fairly common. In years where they spray fungicides prior to at full bloom, prior to a rainstorm or something like that to protect the crop, we'll notice that the larva that's at a certain stage right there will develop completely and become fuzzy and will die as it is emerging.
Oh man.
And then they're pulled out and they
And then they're
look
pulled
like,
out.
but they never really made it out. And so, and I think Reed Johnson would corroborate this. I'm not too sure it was a fungicide or was it a combination.
I think it was a combination of the insect growth inhibitors.
I think so.
Yeah.
But I can't remember exactly what it was, but we still see it. I mean, Tim, you guys see it, don't you?
Yeah, we see it.
Yeah.
Every year.
Well, I feel like, that is, could contribute to some of the common things I hear from beekeepers where they see a delayed drop in population, but it's delayed in the sense it's several weeks after they think that they brought them out of the cropping system. And if that's the case, if you lose your nurse bees, what happens to that generation of brood? If they don't replace the older generation, what you're seeing is normal die-off and not enough workers to replace that. So I think that there are ways that we can mitigate some of those losses and prevent it from spiraling too far down, where then you have to combine and then you have to do all these other things. Yeah.
Our problem in our area is more new beekeepers will blame pesticides when it's actually their management.
The mites.
Well,
Yes.
even feeding,
Or even
they
feeding,
have
yeah.
bees dying in front of their hive
Yes.
and they actually failed to feed a new hive. And they blame it on pesticides that they assume somebody has sprayed in the neighborhood.
Well, I gotta say, it's really easy to blame pesticides because it's this little black box. The beekeepers don't really know what to do with. They can't see it coming in. They suspect it's everywhere, and they're true, and it's true. But this is what I'm talking about in terms of empowering beekeepers to try to figure out, is it really a pesticide thing? Is it a management thing? Is it something else? And I'm trying to shift their perspective, and it's not whether or not you have EFB or the crud or this. It's that your colonies are weak and they're stressed out. Let's figure out why. Is it, are you not feeding them properly? Are you not requeening them when you need to? Are you not managing the mites like you should? So there are all these other, I feel like, more dominant stressors, but oftentimes we get, kind of stuck on, well, these 12 larvae on this one side of this one frame has this, and it really looks like I have a problem. And I'm trying to distill, kind of calm them down a bit and say, look, that's very minimal in terms of the total brood, but there might be something going on with that frame. Let's figure out a way to better assess which frames to cull out of your colony rather than throwing everything out every year or replacing 3 frames randomly. I don't know if that's really the way to go. Yeah.
When you say the crud, is that an accumulation of stressors, or is it something that has so far been unidentified?
It's been, well, it's been given a name. So no, it is a combination of things. And the running theory is that it's when your colony has been weakened to a state, you've got larvae that are in these, frames. One could be expressing one virus, one could be expressing a different pathogen. The point is that something is suppressing their immune function, and now all these other things are coming up and being symptomatic,
So
like
it's
just.
immunodeficiency.
I believe that it is associated with that, but like they said, these stress diseases are indicators that there's something underlying going on. And we those triggers, malnutrition, loss of workers, mite loads, and pesticides, those are very common triggers for a lot of different types of diseases and things that we see manifested. So I guess I'm just trying to find a good balance of like spending your time worrying about what exactly you have, or spend your time figuring out what is the underlying stress.
So if you have the crud, your hive is weak, you're not sure whether it's CFB or crud, what is the trigger to go to the vet and get antibiotics?
That's EFB.
EFB.
EFB, yeah, European foul brood. You need a prescription now to get terramycin and
What should be my trigger to take the effort to go to the vet and do all that?
Well, there are actual beekeeper operations, I think in the Northeast, that are having some EFB outbreaks, and this is like a lot of frames, a lot of colonies in the apiary. So that at that point, you really do need to get it under control.
So I'm worried about it. Should I send a sample into you guys to say, is this EFB or not? Then go to the vet, or do I just go to the vet?
That's the problem. A lot of vets don't have that expertise. It depends on your state. I would definitely connect with your state apiculturalists to see what those resources are.
We don't have one.
I don't know that one either.
It's me.
Yay, it's Kelly.
Judy, has anybody
These
done,
only approved products. They were.
has anybody done a study where they've made a synthetic artificial nectar and compared a synthetic nectar versus like just feeding with sugar water? I mean, because I made an artificial nectar, we did a small study, but I would think that an artificial nectar, nectar is very different than sugar water. There's a lot more nutrition in nectar.
Yeah, that might be a question for Nick, because
Okay.
he's working on more additive stuff and sugar syrups, but Yeah.
Okay.
Yeah, I don't wanna speak on.
But you don't know that somebody's done that.
Nick is probably more familiar with
Okay.
that realm of
Okay.
supplements.
I don't know, since I'm from Oregon, I don't know, but if you're gonna need a vet in order to get any antibiotic for your bees. And
Yeah.
you should be looking around to find, every vet won't do it. But there are those that are aware of it, and you should find out and get their name and ask them, well, what, you're not supposed to be buying it and using it prophylactically, but every vet will have they have to establish a relationship with you.
Yeah.
And that means something different to all of them, but it's really worth ahead of time, before you have a problem, finding out who it is in your area who will do that, and you can go to them when you do need some help. And so, I mean, that's just some advice, and out here, I have no idea.
It's the same thing. You can't just call a vet and say, I need some antibiotics. They're like, well, I don't even know anything about bees. I don't know you,
But
Yeah.
this is my time.
somebody around here, the commercial guys would probably be able to tell you that if you have any around you, where they are able to get antibiotics, and then you can establish that relationship with the vet ahead of time. It might be just a visit to their place, or he might want, or she may want to come out and visit you and see your operation, and they may need some samples. The other thing on these things that require antibiotics, there are some tests you can get for yourself. And the crud will almost always come out, well, it looks like it's EFB, but so you should invest in a couple of these tests and have them around, so that when you're worried about it, they have them for AFB and they have them for EFB, and they're really pretty effective. So just some advice.
Let's thank Judy one more time. Our next speaker from Washington State University is Dr. Yi Zhang.